In this video, we are going to look at the problems in section 12.4. We're going to start with these problems where we're asked to rewrite the imaginary numbers using the letter I for the square root of -1. To do this, we start with this square root of -9. We rewrite this as the square root of -1 times 9. That's the square root of -1 times the square root of 9, so we can rewrite that as I times 9, or 3 rather, which is the same as 3i, which is usually the way we would write this. For the square root of 25, again, we're taking the square root of -1 times 25, which gives us the square root of -1 times the square root of 25, or 5i. For the square root of -7, we do things a little differently because the 7 is not a square number. So instead of rewriting this as two square roots, we can just take this as the square root of -1 times the square root of 7, and then just change that to I times the square root of 7. Notice that we write this as I times the square root of 7 rather than the square root of 7i, because if we write it as the square root of 7i, that kind of looks like we're taking the square root of I as well. So we'll always put that first before the square root. Moving on. Next problem, we're asked to simplify these powers of I. Okay, well, the rule here is that the value depends on the power. This is I to the 4 times 3 plus 3, which is equal to I to the third power, which is -I. If we get I to the 20th, that's I to the 4 times 5 plus 0, which is equivalent to I to the 0, and anything to the 0 power, except for 0 itself, is 1. For I to the 33rd, that's I to the 4 times 8 plus 1, which is equivalent to I to the first power, or I. And finally, I to the 18th is I to the 4 times 4 plus 2, which is equivalent to I squared, or -1. Our next problems ask us to rewrite these numbers in the form a plus bi. 5 is just 5 plus 0i. The square root of 36 is equal to 6i, so this is 0 plus 6i. -3i squared is -3 times I squared is -1, so that's a +3, which is 3 plus 0i. And finally, we've got 6 minus the square root of -5, which is going to be 6 minus I times the square root of 5. For our next problems, we're asked to combine these complex numbers. Combination in algebra is addition or subtraction. We can do that without too much trouble. We start with 3 plus 5i plus 8 minus 2i, which is equivalent to 3 plus 8 plus 5i minus 2i, or 11 plus 5 minus 2 times I, which gives us 11 plus 3i. For -3 plus I minus 7 minus 4i, we get -3 minus 7 plus I plus 4i, which will give us -10 plus 5i. Finally, we have a -2 plus 5 plus 6i, and I can just rearrange my parentheses here to get -2 plus 5 plus 6i, which gives us 3 plus 6i. In our next problem, we are asked to use the FOIL method to multiply 5 plus 3i times 6 minus 7i. To do this, we just do exactly what we've done with FOIL in the past. We multiply our first terms, 5 times 6. To that, we add the product of our outer terms, 5 times negative 7i. And then the product of our inner terms, 3i times 6. And then the product of our last terms, 3i times negative 7i. That gives us 30 minus 35i plus 18i minus 21i squared. Well, we can rewrite some of this. First, we'll take our 30, that's fine, and then negative 35 plus 18 will give us a negative 17i. But I squared is a negative 1, so that's negative 21 times negative 1, or plus 21. So we've got 51 minus 17i there. Here we're asked to multiply these complex conjugates. Product of complex conjugates is just the square of the first term plus the square of the real part of the second term. So here, that's going to be 7. Okay, well, that's 7 squared is 49. Plus 3 times 3 is 3 squared, so that's 49 plus 9 equals 58. The second one is a little more complicated because our first term is the imaginary term. 5i squared is negative 25, and then we are going to subtract minus the square root of 2 times the square root of 2. That's minus 2, so that's negative 27. For our last set of problems, we're asked to square these complex numbers. We can do this using the same procedures as squaring any binomial. So to square 3 plus 5i, we square the first term. That gives us a 9. We take the product of 2 times the product of these terms. So that's plus 2 times 3 times 5i. And then we square the last term, plus 25i squared. Okay, well, that gives us 9 plus 30i minus 25 is negative 16 plus 30i. For our second problem here, we have 5 squared is 25 minus 2 times 5 times 2i minus, plus negative 2i squared okay. Well, that is going to give us 25 minus 20i minus 4, which gives us 21 minus 20i. That's it for this video. If you have any questions, please get in touch.